Hello, welcome to everyone. In this video, this is lecture number 5 on digital electronics. Today we want to discuss about the digital circuit, product term, sum term in logical expression, then sum of product and product of sum and their mixed expression, and then min term, max term in the expression, then conversion between to trivial and logical expression, and simplification by logical expression using Carnot map, right? So you can see this is the syllabus of University of Calcutta, 6th semester. This portion already covered previous lecture. This portion already covered. In this portion we covered this part A. Today we want to discuss this part B, right? So if you want to watch the previous this portion, you can go through the description box. There is a link of playlist. You can go through the one by one video for this portion. Today we want to cover up this portion, right? So let's start. This is the upcoming portion we want to cover. First, you can see that is the product term and sum term in logical expression. You know, from in the AND gate, the output is the product of the inputs. So the output is the product of inputs. So this is the product term in logical expression. So when the outputted from the AND gate, the output is the product term, and similarly for OR gate, this is the sum term. So this is the product term and the sum term. Then sum of product term means first you product the identities and then sum up, right? So this type of expression is known as the sum of product term. And in the opposite, in the product of sum, you can see here, this is the product of sum term, right? So in the sum of product term, this is the format, and there is the three term are like that. This is sum up, right? So this is the boolean sum of the ANDed term, because in the AND operation you make this product. Here the min term, what are the min term? Here this is the three variable a, b and c. If presents the all these three variable, that is the this term a per b per c, in this is the term is the min term, known as the min term, right? So in the sum of product term, the all the variables are available in this term, in the expression, right? So this is known as the min term. Here this a bar b bar c is min term, because all the variable present here. And if all the min terms present, only min terms are present in the expression, like that, a bar b plus c bar plus a b c bar plus a bar b c and a b c, this is the term where you can see all are the min term are present here. If all the min terms are present, only min terms are present, then this is called canonical or standard sum of product term. So I think clear about the nomenclature. Now take an example, take the notation. You can see, so suppose there is three variables, so there is a possibility of these 8 min terms, and their binary equivalent will be like that, and their decimal equivalent like that. So they are nomenclature as like that, a small m0, because these are taken as this min term. So this is small m0, small m1, small m2, like that, right? So if there is a expression like that, so if you equivalent to this, that is 0 1 0, this is 0 1 0, this is 2, so this is m2. Similarly this is m6, this is m3, this is m7, right? This arranged in the ascending or descending order. So if you write up in a summation form, so this becomes like m2 3 6 7, right? Or you can note it like that. So this expression can be represented as like that, okay? So this is the sum of product term. Take an example, write down the decimal notation for the following canonical sum of product function. So there is 4 variable, right? That, and if you equivalent all these things in binary and then decimal, you will be get 0 3 9 15. So only these 4 terms are present here. You can represent it in the summation form like that. In another example, consider the following two table of a 3 variable switching function and find the canonical sum of product expression for this function. So this is the function, and if you want to write down here from the truth table, that is this one is present here, that is x2 bar, x1 bar, and x0, x2 bar, x1 x0, and for this one you will be get x2 x1 bar, x0 bar, x2 x1 bar, x0 bar. For this one you can write down that is the x2 x1 bar, x0, right? So you will be obtain this 5 term, and this is nothing but the m1, m4, m5, m6, m7, right? So in the summation form you will be write down here. So this is the notation of the sum of product term. And product of sum term, for example, this is the product of sum term, and you can see this is the sum up of this the product of this summate term. So this can be written as odd term. This is for product of odd term. This is the odd term, product them, right? Here this is known as the max term. In case of sum of product, this is known as the min term, and in case of product of sum, this is known as max term, where max term means there are all the variable present here. For example, a, b, c bar is present, all these three variable present here. So this is known as the max term of this expression, right? And what do you mean by canonical or standard sum of product? If all the expression present here are the max term, right? Like that in the previous one, all are in the min term. These are known as canonical sum of product term. And here, if all are the max term, then this is known as the standard or the canonical product of sum term. Here you can see all are the max term. Next thing, if you have a three variable like that, so there will be possibility of 8 max term. So this is with the 8 max term, and here these are the complement inverted notation actually. A taken as 0, a bar taken as 1, right? So the notation will be like that. In case of the product of sum, a taken as 1 and a bar taken as 0, but here the inverse, right? So these are the max term notation. For example, this is the fourth term, and if you equivalent this a taken as 0 and b bar, the bar is taken as 1, so you will easily obtain this term. And this is, since these are the product, so taken as a pi, right? So this is the max term or product of sum notation. For example, write down the following canonical product of some function using the max term decimal coded. So these are the four term, and if you equivalent into the binary, so this is 0001, so this is m1, this is 0100, also m4, like that. So you will obtain this 1, 4, 10, 11, and 13, right? So this is the product of sum term. And from the tabulate form, from this tabulate form, if you want to find out this product of some expression, you will take the zeros, okay? And these zeros is this x2, x1, x0, and similarly this one, okay? So you will obtain these three terms. So these two are equivalent, previous one. So already we discussed the min term and max term. That is the in case of the product of sum of product. In case of sum of product, if all the variables are present, this is called the min term, and in case of product of sum, if all the variables present, is called max term. And interrelation between min term and max term is like that. That is the small m is the min term and the capital M is the max term, is not a node or the inverted term, like that. Okay, so in case of small m5, that is the a, b bar, c, and in case of capital M5, you can see here using the De Morgan theorem, that is the if you take small m bar, that is the a, b bar, c taken bar, so you will be obtain a bar plus b bar bar plus c bar. So this is nothing but a bar plus b plus c bar. So one of them is complement, like that. Okay, so if you as a example, if you have a expression in the sum of product term, you expand this one. If you take this complement, you will be obtain this one by De Morgan theorem. So this will be the convention, that is in sum of product term and product of sum term, right? Sum of product term and product of So is like that. Okay, is a complement, right? And if you want to convert from truth table to expression, just two example we already discussed. In case of product of sum, you take this one, right, and a taken as 1 and a bar taken as 0. But in case of product of sum, you taken the zeros and a taken as 0, a bar taken as 1. Okay, so these are the expression of these two. Next thing, now you need to know about some Boolean identities. Further, you can understand the Karnaugh map, right? Some Boolean identities. Suppose you have 0 plus a. What will be the value? This will be a. Because if you take a equals to 0, you will be obtain 0 plus 0, which is nothing but 0. For that, I think you know about this Boolean identity, that is 0 plus 0 is nothing but 0. 0 plus 1 is 1. 1 plus 0 is also 1. And 1 plus 1 is nothing but 1. Right? High plus high. This is not binary addition. This is Boolean expression. Right? Similarly, 0 into 0. 0 into 0 is nothing but 0. 0 into 1 is 0. 1 into 1 is 1. Okay? So for that, you can write down that is 0 plus a is nothing but a. Why? If you take the value of a, that is possible is 0 or 1. So 0 plus 0 is 0 and 0 plus 1 is 1. So depending upon this element, so this is a. Similarly, 1 plus a is nothing but 1. Why? Because 1 plus 0 is 1, 1 plus 1 is 1. So 1 plus a is 1. A plus a is a. Why? Because if you take a is 0, so 0 plus 0 is 0 and 1 plus 1 is 1. So it depends on a. Similarly, you can write down a plus a all are 3a. That is, you can write down this 3a also a, because a plus a is a and a plus a also. If write down this 1 plus a bar, this is also 1, because if you take this a is 0, this become 1 plus 1, 1 plus 1, that is 1. And if you take a is 1, so this is 1 plus 0 is 1, right? So these are the identities. And if you take the product, that is the 0 plus a, what will be the 0? Because if you take a equal to 0, this is 0 into 0. And if you a equal to 1, 0 into 1, 0. So 0 into a is 0. If you take 1 into a, this is a, because if a equal to 0, so this 1 into 0 equal to 0. If a equal to 1, 1 into 1 is 1. So depends upon a. And if you take a into a, this is gives you a. If you talk into a into a, this is gives you a, because a equal to 0 gives you 0 into 0. If you equal to 1, that is 1 into 1. So depends upon a, right? And similarly, a gives you a. Now for complement, suppose a into a complement is 0, because if a equal to 0, 0 into 1, that is 0. If a equal to 1, 1 into 0, that is also 0. A plus a complement is nothing but 1, because a equal to 0, this gives you 0 plus 1, that is 1. If a equal to 1, 1 plus 0, that is also 1. So these are the Boolean identities you need to know, such that you easily obtain the Karnaugh map solution. Because in Karnaugh map, you given some expression, and you need to simplify that. You need to reduce the formula or function, such that you can implement this function using gates, right? So this is our motive in the Karnaugh map, such that we can reduce the expression and then implement using the gate, right? So in Karnaugh map, if you take a one variable, that is the x, so x bar x m01, or you can note it like that. Okay, you can note it also like that. For two variable, that is xy, that is 0 1, that is 0 1. So this block is nothing but x0 y0. This is x0 y1, this is x1 y0. So if you equivalent to this one, you can see there is small m0, small m1, capital M0, capital M1, like that. Small m0 is nothing but is x bar y bar, but capital M0 is x plus y, right? In in an example, you can see there is a 2 and 3. This is 0 1 2 3, right? In the notation, this is 0 1 2 3, right? 0 1 2 3. So gives you these two are 1, small m, that's why 1, and that is x bar. So x bar is 1, that is where x is 0, that's 2 term is 1, right? And 0 2, that is capital M, so in terms of 0 1 2 3. In case of 0 and 2, there is a 0, right? Because this complement is nothing but gives you this one. Okay, next thing, for three variable, you can see this is the 0 1. This is the change you need to notice here, that is 0 1, this is 1 1, and this is 1 0. That's why 0 1 2 and 3 here, 4 5 6 and 7 here, right? So similarly for this is sum of product term, and this is product of sum term written here. For example, this is the notation. You can see this is a bar, that is 0 1 1, that is 0 1 1 is 1 here, that is 1 0 0, that is 1 0 0 1 here, and it is 1 1 1. Okay, 3 and 1 here. Similarly for this expression a and b plus bc, when a is a 1, all are 1, and bc, that is b and c is 1, all is 1. Okay, so you can write down in this format. For four variable a, b, and c, d, 0 1 2 3 4 5 6 7, 8 9 10 11 12 13. For example, if you consider this one, this is 0 2 3 7, all are 1, and rest of the 0. For product of sum term, this is 0 0 5, this term is 5, or 0, and rest on the 1. Okay, and you need to write down in the zeros format, right? Here, if you want to solve this or reduce in this format, you need to take the ones, right? Suppose, and this one is taken, this one actually taken in the single or two or four or 8 or 16, like that. So if you take this 4 1, you can see here the constant term is a and b, cd are change, so a b bar, that is a b bar. For these two, you can see there is a constant a and there is a cd, so this actually returns as a and c bar d. Okay, and if you take this two, these two, you can see there is a b is constant and c is constant, that is b bar c. If you consider this two one, you can see that is a constant, that is a bar, and this is cd. This one and this one is taken because this is closed. You can say that is b bar C bar D bar. So there is 1, 2, 3, 4, 5. 5 are term reduced. Here you can see 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 term reduced to 5 term. This is the simplification. For here, if you write down in the sum of product term, you can take these ones, and if you take this for 1, you can write down that is the these two are present a constant C d bar. For this 4 1, if you take this 4 1, you can see that is A is constant and C is constant, that is A bar C. Okay, for these two, if you take these two, you can see that is D constant, here A B constant. So A bar B bar and this is D. For this one, you can see there are 4 things here. You need to write down this 4 term. That is A, B, C bar D, right? And for this one, these two are taken, and you can write down that is A bar B, and here, here, D constant. That is A bar B and D bar. So these are the expression, that is 1, 2, 3, 4, 5, right? But in case of in this term, you can write down in these zeros. If you take these zeros, you can write down in this form like that. That is, if you take this 0, you can write that is A plus B plus C plus D. Then for this 0, this is single also, you write down that is A plus B bar plus C plus D bar. You need to product them. And this 2 0, if you consider, then this CD and here A bar. So A bar plus C plus D, right? And if you take this 2 0 and this 2 0, if you take this 2 0, you can see that is A bar and this is C bar D bar. A bar C bar D bar. And if you consider these 2 0, you can write that is A bar B, A bar B, and here the D bar. So here 1, 2, 3, 4, 5 term. Here also 1, 2, 3, 4, 5 term. So these are the two notation. This is product of sum notation and this is sum of product notation. This is sum of product notation. So these two notation actually used to simplify the Boolean expression using Carnot map. Here the example, you can see this is the function given here. Find out the minimal sum of product form. So you can see there is a 0, 1, 2, 3, all are 1. So this is 1 independent of x. This is the simplification. In case of this one, you can see 0, 1, 2, 3, 6, 0, 1, 2, 3, 6, 1. So these 4, and you can see in this 4, this x is constant, that is x bar. And for that one, this is y and z are constant, that is y and z bar. So the solution will be there. So there is a 5 term, and in the simplification there is only 2 term. This is an expression 1, 3, 5, 6, and this position you taken as a 1, and if you do not return here, actually these are the 0. So if you take this 4, you can see there is a constant of this A, that is taken as A bar, and there is a constant D. This is for this 4 cell. A 0 is constant and D 1 is constant. So A bar D. For this 2, there is a constant of B, there is a constant CD. So B, C bar D. For this one, AB and C is constant. A bar B is constant. And for this one, this is single one. So 4 term. So this 7 term reduced to 4 term. This is the simplification. So I think clear. Here is some previous year question. Here give you this to travel and you need to solve this one. This x is nothing but don't care condition. This x is nothing but don't care condition. This is don't care condition. What do you mean by don't care condition? That is independent upon of this output. The output is independent of this condition. So if you put, actually this x can be taken as 1 or 0, so you can take it in case of sum of product and the product of sum as well. So if you put in this expression, that is, you can see here 0 0 0, this one 0 0 1 0 0 1 x. Okay, so in this process, if you plot in this table, you can see here that is this 4 1, actually a bar which is constant. For that one, that is b c bar is constant, and there is a mistake. Actually, not mistake, this is right, because two don't care condition do not be taken here. You need to take one side of one, and in the middle, if there is a don't care condition, you can consider, but two don't care condition is not, does not taken here, right? So this is the solution. For this one, you put these things and easily solve this one. I think you understand up to that one. And this is the to travel wheel by like that, and there is only two, one, two, three, four ones here, and these are interrelated. Here you can see there is C is constant and AB is constant, so A bar, B and C bar, and for that one, AB constant and there is D constant, so ABD constant. So if you just taking this B is common out, the expression will be like that. And if you wants to implement using get, you will be like that, that is A bar, this is C bar, this is A and D product here, and there is sum of, and then if you product, so using or get, not get, and get, you you can implement this circuit. Okay, this is your homework. You must do this using boolean expression simplification or the Carnot map. You need to simplify this one. Okay, I suggest you all of you to solve this using Carnot map. Okay, and you must comment in the comment box if there is any doubt on this class, and if there is any problem to solve this question, you must comment in the comment box. So that's it for today. This is all about me. This is my contact detail. You can connect me with this Telegram channel, and this is my YouTube channel details. Go to this channel. You'll be get different physics related videos, some mathematics. Like this session, if you learn something from this session, share this video to your friends. Either he or she also get benefit from this video. Subscribe this channel if you need this channel. Those already subscribed, thanks for subscribing. Hit the bell icon to get notification of upcoming video. So take care. We'll meet in the next video as soon as possible. Thank you.